To give a little bit of background on why I think it's a good idea for you to choose IGCSE Physics, which is Cambridge Syllabus 0625. So you could Google yourself the reasons why it's a good idea to study physics, but here's a nice quote that I found, that physics helps you to understand the world around you and satisfy your curiosity. Studying physics develops your critical thinking and problem-solving skills, which any employer is desperate to find, and it's totally useful life skills that you can employ in your life in any way. Physicists are versatile, which opens a wide range of future careers, and I'll talk more about those later. Physics drives technology advancements, impacting society, the environment, and the economy. You could also think about these 10. So studying physics helps you to find out the way the world works, the way that it does. So that could be from the biggest things like the universe and looking at the Big Bang. It could be to looking at really small things like atoms and how they interact. Or it could be just working out how your phone works. What's the technology inside of there? You can solve problems, so you can ask questions, you can do experiments, you can solve those problems. A lot of physics, a lot of the physics that you study will be solving problems, and as I just said, they're completely transferable skills to anything else that you do in life. There's a wide range of career opportunities, so really obvious things like engineering involves physics. It's really useful if you want to go into medicine, if you want to go into computing or ICT, and I'll talk more about those things again later. It keeps you on your toes, so you're always meeting new problems and solving new problems. It complements different subjects, so a few examples would be maths, so you get the chance to practice your math skills. You can find out why some of the things that you study in maths are transferable to physics. In chemistry, there's a lot of crossover, so nuclear physics and chemistry are very closely related, and ICT and computer science. You could also think that studying physics gives you a challenge, and crucially, employers and universities know that it gives you a challenge. If you come out with a good grade in physics, whatever you're applying for, whether it's a course or a job, they will know that you have been challenged to get that good grade. You could work overseas, so all of the physics is transferable. Obviously, physics is the same wherever you go, the laws of physics. You acquire skills that are valuable to employers. You appreciate modern technology, and you can help in the development of that and keep abreast of that. And you can embrace postgraduate research opportunities. So physics is still developing. We don't know everything. There are huge amounts of information that we don't know. And postgraduate physics students are doing research into that. So in terms of the course, there are 6 major topics that you can see on the screen there. And I'll just give a little bit of background about each of those. Okay, so in terms of motion, forces, and energy, you're going to start by looking at things like velocity, speed, acceleration, distance, and displacement. So a good way of thinking about that would be how you would measure the speed of those runners as they go across, to run for 100 meters. What's the difference between their average speed and their instantaneous speed? You can also think about that in terms of forces. Why, when they push back on the blocks, does that mean that they get pushed from the blocks and make a good start? And a lot of these ideas relate back to Isaac Newton and his 3 laws of motion, which underpin a lot of our understanding of how objects move and why they move. So even though he was thinking about this in England in the 1600s, hundreds of years later, his basic ideas were used to get man all the way to the moon. And a way that we might study this in the lab is using the air track like this, and put these little trolleys on, and they go backwards and forwards on there because there's very little friction, and we can use these light gates to study that motion. We can also, in motion, forces, and energies, a large part of it is about energy, which is one of the most fundamental ideas in physics. It helps us to study, well, going back to those that air track, what kind of energy they have. It helps us to explain batteries, how plants grow, how light bulbs work, all of those things. We can also study how we generate energy. So using a power station like this, how can we put coal in there or wood and end up with electricity when you plug your laptop charger into the mains? And why that kind of technology is useful, but why it can be dangerous in terms of the environment, and why there's more and more countries that are switching to using renewable energy sources like these wind turbines. Thermal physics is the second of the topics. So very simply, it's to do with heat and the movement of heat. So in terms of a Bunsen burner, we could think about convection currents in a hot air balloon. We can see the little fire at the bottom of that. Why does that make the hot air balloon rise? And then how do you make the hot air balloon come back down again? And as well as asking those big questions, it'll also answer some very everyday things, like what kind of days is it best to dry clothes on? The third major topic is waves, and there's lots to this topic. You know what a wave is when you think about a water wave. But also, there's lots of other things that travel as waves, and we can't see the waves, but we can see the effects of the waves. And we have two types called transverse and longitudinal waves. An example of a longitudinal wave would be sound waves. So what's happening when you listen to some music from a speaker, as you're listening to me speak now? We can think about light rays. So this is an example where we can almost see light traveling. We can see it traveling in straight lines through those trees. And there are so many applications of waves that are useful, vital to the way that we live today. For example, a microwave oven, the name suggests it uses waves. One that's being used more and more if you're going through a body scanner to scan your temperature because people are worried about you having COVID. This person here at 38 has got an unusually high temperature, and so they might have some kind of infection. Loads of other examples of waves would be the fact that you're connected to Wi-Fi now and you're listening to me. That's traveling as a wave. The fact that you were getting heat and light from the sun, that's traveling as a wave. So waves has got a huge number of modern applications. In terms of electricity and magnetism, we would start off by looking at what's static electricity, and a really good example of that would be looking at lightning. Then we would get the Van de Graaff generator out, which you may have seen, and it will make people's hair stand on end. So we're thinking about, well, why does that happen? What's the link between the lightning and why the hair stands on end? And when we've got that idea of what static electricity is, we can look at some more everyday examples, like how do you get that light to light? What do you need to get that light to light? And then looking at magnetism, we would look at ordinary magnets, as you have looked at in Key Stage 3, but also electromagnets and how we can use those to make things like a motor. So we'll make motors, and kind of the opposite of a motor is what's inside a power station is a big generator. So if a motor transfers electrical energy to kinetic energy, this does the opposite. So the kinetic energy inside there spins around, and we use that to generate electricity, which is how you're getting the electricity in your home. And then the next to last topic is nuclear physics, which links together. Nuclear just means the nucleus, which is the inside of an atom, the tiny little bit in the middle here. Okay, and it links that together with ideas such as making a nuclear bomb or using nuclear fuel in a power station, or some more everyday examples. If you have a smoke detector in your house, that uses nuclear radiation to detect whether there is smoke in there. This topic links really, really well with chemistry. If you do an IGCSE chemistry, you'll find this topic much more straightforward. Lots of the ideas about what's inside an atom are also in chemistry. And then the last topic is a new topic, okay, is space physics. So we'll look at stars like the sun, which is there, and you can see this solar flare coming out of there. and think about what is happening there. What is the sun? What's it made out of? Where does it get its heat and light from? Then we can think about what's inside our solar system. So we can see the sun again there, and we can see the planets going out. But also, as well as that, we'll look at some really huge ideas by starting looking at galaxies and thinking about, well, why are all the galaxies moving away from us? How do we know all the galaxies are moving away from us? How can we measure that? And that's something we'll look at. And then that leads you into the ideas about the Big Bang. And what is the Big Bang theory? Why do physicists think this is the way that the universe expanded from a single point? We can think about whether there's any other theories that might be able to explain this. We could think about what was there before the Big Bang, what will there be there after the Big Bang in lots and lots of years' time. So some huge ideas involved in space physics. So that's the last of the topics. So the only other thing, well, two more things I was going to say is how you'll be assessed. This is the same for physics, chemistry, and biology. You do a multiple choice paper and a theory paper, which are written answers. You either do 1 and 3, which means you can get grades G to C, or you do 2 and 4, which means you can get grades C to A star. But the format of the two tests, 1 and 2 are the same, and 3 and 4 are the same. And then everybody, regardless of whether you're doing core or extended, does an alternative to practical paper, which lasts an hour, and it's based on experimental skills. So it will ask you to design experiments. It'll ask you to analyze results from other people's experiments, to draw graphs and draw conclusions and so on. So that's the course. And then the last thing was to think about, again, where can physics take you? Engineering. So you could be an electronic engineer, a civil engineer, a mechanical engineer, a software programmer if you go into computing, a web designer. You could become an electrician, a plumber, a geoscientist looking at the earth. You could go into research scientist, become a physicist, a statistician, mechanics, air traffic controllers. You could go into construction. There are so many, including medicine and all those other types of things. And you can look those up yourself. But I wanted to give you some ideas. So that is it. That's the end of my talk. So if you need any more information, you'd like any more information, then you can email me. My email is on the school website if you don't already know it. Okay, thank you very much. Goodbye.